Industrial and Systems Engineering. So today I'll be talking about condition-based maintenance of rotary machinery. So the upcoming slides, in the outline of our presentation, we have created in two parts. So the first part is like introduction section, which will be covered by me, and then second part will cover my colleague Anta. So talking about like the introduction, we will discuss three main points about condition-based maintenance. So what are the maintenance strategies? What is condition-based maintenance? And using machine learning based fault diagnosis in rotary machinery. And part two actually, Ayanta will talk about introduction of different types of bearing faults, and then experimental setups, results, and some summary conclusion. So before starting of the, so then the motivation is that in the slide in the top right corner, you can see that a failure percentage on a pie chart. So that is a induction motor failure. So we can see that in that failure categories actually the bearing force is responsible for 41%. That is the major share of that force. And then the second one is like stator force of a motor. And other rest of the two forces are associated with like a rotor force and then other type of machinery. So bearing is a crucial part, or you can say that important elements of a rotary machine. Let's talk about some benefits of maintenance. So obviously, if we think about like a rotary machine or any kind of machinery, so all type of machinery actually require maintenance work, and gradually their parts degrades when you do know the time elapsed. So there needs some maintenance work on that. So another concept is like every piece of material which reach to the end, and that is also useful of the healthy life. So it's kind of a trade-off between the maximum use of machinery and then how we can get it most outcome from that machinery. And the another major benefit is maintenance is reducing the like a downtime cost and unexpected machinery failure. So in the figure, you can see that the machine health. So it's like a gradual decreasing curve. So while we start a machine, for example, a new motor can install in a machine, and so then that covers like under warranty. So if it is false or any kind of faults or any kind of problem, that will be covered by the manufacturer or that the company that provided by the motor. So in a gradual chronological time elapse, so we can see that what type of uh, like happens in gradually. So in the case year two, we can see that it's ongoing scheduling maintenance, and the year and then succeeding year fault, that like a fault inception. So kind of after a certain point, then the fault starts of a machine, and then other succeeding time we can see that the later months we can use different types of sensors like vibration or ultrasonic microphone sensors for detect the faults and so forth so on. So this is the idea about how to possibly detect a fault of a rotary machine. So there are some three basic strategies of maintenance. We will cover them all here. So the first one is reactive maintenance, and the second one is predictive maintenance, and the last one is predictive. Sorry, the second one is preventive maintenance, and the last one is the predictive maintenance. So I will talk to the next slide. So in reactive maintenance, actually, the idea is fixing a part or machinery that experience any kind of like a broken condition or fail. So and the impact of the reactive maintenance is really higher than any kind of maintenance work, because if we think about a manufacturing plant, so if a machinery fails in during production, so it's really creating problems for the like production and associated other activities. So in a given figure, we can see that idea about like a reactive maintenance is kind of we can see that like in mm, uh, the the diamond shape of the car. So for example, if a machine fails, so or occurs, so then there are two possible things can happen. If it is occur, that means we need to perform that maintenance. So if it is no, so then we will like keep running the machine. So or we observe the equipment, let's running it. So and then talking about like preventive maintenance. Uh, Preventive maintenance is sometimes also called like a planned maintenance that consists of several duties that fulfill machinery under a current operation to avoid sudden failures and also reduce the downtime and related costs. And another strategy for preventive maintenance that like a machine and then the activity is actually like conducted by the offline of a particular time. So actually then it hampers the production time while in a running production plant. And the another the concept of preventive maintenance to increase the like life machinery. Also, this is also covers like other like concept like reactive or preventive as well as the uh, yeah, preventive maintenance. But if we think about the improve the productivity or overall gain accuracy, it also helps to reduce the maintenance expenses in preventive maintenance work. So in the given 5 points, we can see that like the preventive maintenance work actually follow several steps. So for example, initially we'll define a goal or priority of maintenance work in a plan, and then we will make a list or task that which machine should go, and then which one should be like check initially, and then it's follow like order. And these are that like managing priorities and resources. So it covers like priorities of the which machine should go first and then which should go last, and then also associated with it like a manpower who will be conducting this maintenance work. And based on that, taking the performance of the machine, and then we will calculate the some performance indicator. So which machine is showing better performance, which is showing like a bad performance, and based on that, we will prioritize those machinery and then take initiative to improve the machinery condition. And the third part of the like maintenance work is predictive maintenance. So it's like a most a new one and also widely practiced currently in different types of manufacturing industries. So the idea is predictive maintenance actually it investigates on the data analysis that can be incorporated with the sensor vision that can be connected with machine, and it also immediately tests the machine performance regular operation to predict unusual breakdowns, and also it allows like maintenance teams to collect the issues or correct the issues before failure occurs. And another good concept of predictive maintenance that like rather going to the machine failure or repairing that is actually practiced in previous time in reactive maintenance. But in case in predictive maintenance, it avoid like a machinery failure or repair, so as not like a demand basis. So it can prognose or diagnose a machinery for quite a while before the machine fails. So these are the like basic idea about like predictive maintenance. Obviously, there are major benefits of predictive maintenance work. So the idea is that it is like a trade-off between like while like a need-based maintenance, but it will never like a neglect a machine or like a never like a maintained without going for or like neglecting a procedure. So it's like a trade-off between like which one should go conduct the maintenance work, and then we can perform the maintenance, and then we can forecast those maintenance based on the different types of sensor and data analysis. And another major the advantage of that, like it minimize that downtime, so that like we can predict the condition of a rotary machine. For example, like a bearing condition of a rotary machine, we can gather the data using the sensor in real-time operation in a manufacturing plant. So we do not need to like make it offline and stop the machine and then collect the data. So we can do it like in a running condition of a plant. So another well, the advantage of that in predictive maintenance, it doesn't require like maintaining a large inventory of parts on hand, so that we saw that like in our like a reactive in the previous slide about the other maintenance work. So we need to set some the basic like a task like making prioritize, and then have some like work tasks and the people and other machinery to make it offline. So this idea is really better than other maintenance work. And if we consider the productivity of a manufacturing plant, like a just in time. So this is the like main driving force that benefits of predictive maintenance work. So if we think about like what are the basic requirement of like a predictive maintenance, so we can say that like initially we need to collect the data and from the like a running condition of the machine, and then we will pre-process the data, and then we also need to based on the like a early detection of like a condition of machinery and pre-processing the data, we can diagnose those faults. And we can also tell that like time to failure prediction. So when the machine will fail, so it can give us like a prediction in the future. So if we properly maintain this machine, so what is the maximum service that we can expect from a machine? So, and another the requirement is like a maintenance scheduling, and resource optimization is also the basic requirement for predictive maintenance work. So yeah, if you consider based on like a fault diagnosis, so we can classify a fault diagnosis method in two major portion, like a qualitative and quantitative methods. And for qualitative method, it covers two major concepts. So the one is like a graph theoretical approach, and another is like an expert system. For quantitative method, it majorly cover to like a model-based analysis, and another is data-driven approach. While we talk about like a data-driven approach, so it's like a more significant one in like a fault diagnosis under the umbrella of quantitative method. So here the data-driven approach has several steps or several like the categories. We can see that over here, like a multivariate statistical analysis, rough set, signal processing, information fusion, and machine learning. And then later on, we can see that like under this umbrella, multivariate static analysis involves in several methods over here, like a partial least square method, principal component analysis, and other stuffs here. And if we consider like a signal processing, so it also covers two popular methods like a spectrum analysis and wavelet transforms. So these are the two methods actually which has been using for a long time. So these are the two machine learning or popular tools for the machinery for diagnosis system. Yeah, if we see that like the highlighted one, the machine learning, so this is the like most popular one, and nowadays it's been like widely used for classification of all diagnosis method. For example, under the machine learning, we can use like a decision tree, support vector machine, and neural network. In the second portion, actually, we'll be talking about artificial neural network systems for diagnosis of different types of faulty bearings. So now let's talk about the idea about the machine learning. So the idea of machine learning is actually proposed in quite a while ago. That was in 1959. That is proposed by Mr. Arthur Samuel. So he defined what is the machine learning concept here. So the idea about machine learning problems can be categorized into three major steps over here. So the first one is supervised, unsupervised, and reinforcement learning. So in case of supervised learning, we can see that we can classify a given data set for different classes using the classification based learning. And in a regression line, we can calculate different types of the trend line, or we can calculate what is the like a mean, like RMSE root mean squared error, and then we can also find out the loss function and other adjusted R square to get the what is the trend of those the given data set over here. And in the given unsupervised learning for like machinery for diagnosis system. So for example, if you are given like a 10 fault bearing data set, so then we can use k-mean clustering, and then we can cluster those different faults based on what is the number of faults we are given, and then we can classify those things in unsupervised learning. And the idea about reinforcement learning also falls into supervised learning, but we call it like a sequence of these decisions based on like what we have learned in previous time, and based on learning in a previous steps, that is use in a benchmark, and then so forth, so on. So it's kind of a reinforcing the one step and then succeeding steps. So for all diagnosis systems, machinery. So then we can ask that what are the most trending topics in machine learning. Obviously, we'll talk about like a deep learning in the next upcoming slide that will covered by my colleague Ayanta. So if we go through some like literature review about the fault diagnosis using the machine algorithms. So we categorize into like two major sections, like the fault diagnosis using the machine learning algorithms, and then using that like fault diagnosis using a deep learning algorithm. Though the deep learning algorithm also coming from the like machine learning model, but we categorize as like deep learning that has been very popular nowadays. So in the application-based for the fault diagnosis with machine learning algorithms, we can use in different machineries, for example, compressions, like compressor valves, wind turbines, and rotary machineries, as well as the bearing, rolling bearing elements to extract the features, and then we can see what type of patterns inside those like extracted feature, and then we can make a decision about like what type of signals creating problems of a rolling bearing elements, whether it comes from a faulty bearing or a bad bearing. So it's like kind of like a root cause analysis we can do based on that. And in that case, we can use different types of methods. So I already, like I mentioned, about like a wavelet transform. This is very popular tools for like a signal processing or fault diagnosis purpose. And then principal component analysis. Another very popular like method is fast Fourier transform, which is what the name as like FFT. And artificial neural network. So actually, artificial neural network started quite a while before we started the deep learning concept like CNN, and then also some linear discriminant analysis, quadratic discriminant analysis. And if we talk about the fault diagnosis algorithm using the deep learning method, it can be also used in like rolling elements bearing fault detection procedures. And most widely used the methods are like a convolutional neural network and like artificial neural network and then recurrent neural networks. So that's all about the literature review about the fault classification based on different types of methods that can be used in fault classification. So now I will give uh, uh, like talking to my colleague Ayanta, and then you will continue the rest of the slides. Ayanta, are you getting me?
Yes. Can you see my slides
Yes.
now? All right. I'm Anantha. I'm a PhD student in industrial and system engineering. So I'm gonna explain an application of rotary machinery fault diagnosis using machine learning algorithms. First of all, what are these rotating machineries? The rotating machinery is an essentially composed of a rotating part, the rotor, and the non-rotating part, the stator. So this rotating machinery is an essential component in various manufacturing systems such as induction motors, gearboxes, and connecting shafts. However, in these, when we talk about this rotating machinery, the bearing is the prime element of any type of rotating machinery. Any type of problem caused to the bearing is going to be fail these rotating machineries. Let me just introduce these bearings. The bearing types, there are four main bearing types available in industrial and manufacturing system. The one is called ball bearing, then cylindrical roller bearings, tapered roller bearing, and needle bearing. For a specific task, if we allocate a rotating machinery for a specific task, if we need more speed, we use these ball bearings. The cylindrical and tapered roller bearings we use for radial or rotor loads up. If we want to apply more weight on there, so then we use this tapered or cylindrical type of roller bearings. However, any type of these bearing can be failed. The primary causes of these bearing failures are going to be the excessive loads, the fatigue failures, contamination or lubrication and corrosion type of failures. So the bearing faults are going to be two types. So one is a generalized roughness, and the other one is a single point failure. The generalized roughness is always based on the lubrication failure or corrosion type of failures. And in the right hand side, you can see that the most common type of bearing fault, the in A, you see that the inner race fault, in B, outer race fault. These are the most common type of bearing force. In single point force, obviously it is depending on this vibrational frequency. When it is operating under phase, the type of cracks, pits, and spurs can be happen. So yeah, there are four parts of a bearing, mostly known as outer race, inner race, ball, and ball gauge. When it is in a ball bearing, so these are the major parts of a bearing. Let me just explain about what type of health that we want to discuss about these bearings. The fault detection of fault diagnosis of bearing uh, is a challenging task. Why I would say that is challenging because the random faults can appear in any type of operating conditions. The commonly used condition monitoring data is vibration and temperature, pressure, and environmental data. In right hand side, you may see type of vibration signals, and when if we have this type of vibration signals, if there is type of error or type of fault in bearing, the vibration signals is going to be different or deviate from the normal condition. The normal condition, inner race fault, the ball fault, or any type of outer race fault, the time dependent vibration data is going to be changed. The vibration signals are widely used type of signal uh, when we talk about this fault diagnosis or fault detection of bearings, and it is sensitive to many type of bearing faults, and it is very inexpensive. Let me just talk about this application of machine learning based fault diagnosis. So we have selected a data set provided by NASA Ames Research Center to show you what type of fault diagnosis can be done using these machine learning algorithms. So they recorded this data in a time-dependent schedule or time-dependent manner at every 10 minutes. So it will end up with 20 kilohertz of sampling rate. So these one timestamp is consist of 8 by 220,000 vibration data as a matrix. What does that mean? So in this schematic, you can see that there are four bearings. For each bearing has a accelerometer. So actually, accelerometer is going to be used to detect these vibration signals. For each bearing, the accelerometer has been placed to find these vibration signals. Those are in X and Y direction. So the objective of this experiment is to implement this machine learning based fault diagnosis method for bearing degradation using artificial neural network and a support vector machine. So in here, we use this artificial neural network and the support vector machine as a conventional method. As Abdullah explained, in fault diagnosis, actually in literature, we found that fault diagnosis can be divided into two categories: conventional machine learning based algorithm and deep learning algorithm. To show you that what type of uh, things can be observed by this fault diagnosis in the conventional and deep learning algorithms, we choose this ANN and SVM. The performance of these classification algorithms on bearing 2 fault diagnosis is recorded. What does that mean? I mean, there are 4 bearings, but for the demonstration purpose, we choose the bearing 2 to show you how these degradation patterns look like and how we make this machine learning based fault diagnosis method for signal processing. In this slide, you may see the different type of bearing and type dependent vibration signals. Sometimes this is called raw vibration signals, and this is in time domain. So in here, we see this frequency domain data. what we have done here, for any type of time-dependent vibration signal, it can be decomposed into frequency components. If we have these frequency components, so unwanted information can be reduced and important information can be retained by using this frequency domain data. If we have these frequency domain signals for each and every bearing, we calculate the power spectral densities. For any type of signal processing method or fault diagnosis or any type of machine learning based fault diagnosis method may need, as Abdullah explained to you, we need a data collection. After we have this data, we need to pre-process it. Then we need to extract certain features, which we call feature extraction. Then we need to do feature selection. After we have these features selected, we can use that feature to input into a certain algorithm and make or train a certain model. For this specific study, we use the power spectral densities with mid-range frequencies. In bearing 2, as we focus on bearing 2, to see that the important information are somewhere between 1000 hertz and 4000 to 6000. So we use this information to calculate this spectral density, and we observed the degradation pattern. So for your information, I mean, we use these 4 degradation patterns in there. The range of frequencies are selected to calculate this power, and we found that these degradation patterns are in bearing 2 and bearing 3 going to be based on a certain fault. I mean, they have the same type of fault, but bearing 1 and bearing again, for the demonstration purpose, we use this bearing 2 to consider it as a fault diagnosis with bearing 2. I mean, what I mean here is we use bearing 2 to make this fault diagnosis method. Okay, now we are degradation pattern analysis. For any type of degradation, we can choose or we can cut it into different phases. In general, we cut it into 2 phases. One is called normal phase, and the other one is called fast degradation phase. In fast degradation phase, we can have more valuable features than the normal phase. So we select the fast degradation phase, and we define 3 states. What are these 3 states? We call it normal, defect, and failure state. In these 3 states, we may define a certain spectral density cutoff frequencies, and we define these 3 states. Okay, now we are we are explaining. I'm going to explain to you that what type of classification problem that we are going to solve here. So our goal, let me remind that our goal is to use this machine learning method to build this model to predict the bearing 2 health states. So one can imagine that if we have 2 states for a certain for a bearing 2, so then this multi-class classification problem is going to be a binary classification problem, which we call a 2-class classification problem. So then the algorithms are going to be somewhat different than here. But for the demonstration purpose, again, we define 3 states, and based on these 3 states, this is going to be a multi-class classification problem. So we use a random sample of 80% of data to train a model, and the rest of the 20% is going to be our evaluation purpose or testing purpose. Based on artificial neural network, the misclassification rate is somewhere around 0.095, and the support vector machine, it will end up with misclassification rate of 0.108, where we reach the accuracy of 90% for both models However, you can see that the deep learning model, so the artificial neural network based classification model perform better than the conventional machine learning algorithm support vector machine. In summary, we considered this predictive maintenance or condition-based maintenance application for this fault. It comes up to the fault diagnosis, because the fault diagnosis is one of the major practice in predictive maintenance. So PDM identifies the condition of the machines or equipment by monitoring the current operating state. So it will reduce the unplanned downtime or breakdown cost. The PDM uses the statistical process control and machine learning principles to determine what point or what type of failure is going to be happen, or what point in future the maintenance needed. So then the PDM utilize the infrared acoustic vibration signals or sound level measurements, oil analysis, or other specific tests to find out when when it is going to be fail, or type of understanding where we need this maintenance. The vibration analysis is the most productive and effective for rotating machinery fault diagnosis. And we can conduct this vibration analysis to evaluate the condition of the equipment or condition of the machine, and we can avoid failures or unplanned downtime. Thank you. That's all for us today. And if you have any questions, please feel free to ask, or otherwise you can email us. Thank you again.
Abdullah, I think very good presentation. Actually, I really enjoyed. If there's no other question, maybe I can ask a few follow-up questions. So you applied, some of those different algorithms, right?
Yes.
ALN and SVM. So just wanted to make sure. So what is your what is your final goal? What was your target variable?
The target is going to be, Dr. Maruf, is a classification, or response variable is a classification. Three class
Either
of
it is
classification.
fine or it is fault, or it is.
Yes, it's a normal, defective, or failure.
So is this already been determined in the data set, or you did some pre-processing and identify when it is getting out of, or it is still fine, or it is now faulty, or it is now just maybe just already broke down? So is this the item that you determined?
Yes, sir.
So you did some pre-processing and you determined those another column, right? Or it was already there as part a column or a variable in your data set?
If I understood correct, so what we have done here, so we consider this as a multi-class classification problem. So where we have three class defined already, and here you see this. So based on this training data, we allocate this of data on the rest of the 20%. So based on this data, so we observe that the deep learning method can give us a more accurate results than the conventional.
No, I understand that part. Actually, my question is actually one step before that. So my question is that in your data set, did you already have that labeled already? That if you are in
No.
this stage, then this status is normal. If you are in this stage, or you actually did some pre-processing to determine that extra variable column?
Yes. Yeah, that's an excellent question. So now I understood the question. I'm sorry, I didn't understand the previous time. So we defined, so this is the artificially defined states. So as I mentioned, because the expertise knowledge may needed to define these states, when you see this degradation pattern, one can understand, if someone have certain knowledge in uh, degradation pattern analysis, so then he may understand that, what type of states is going on in there. For example, you see this, the power calculated for the bearing 2, it may end up with somewhere uh, uh, 50,000 to 20,000.
Mm-hmm.
But in bearing 3, the power is somewhere not in that. So I mean, we should define to
I think
show
it is getting a little bit
it.
of interrupted, right? I don't know if all of you are
Certain,
experiencing the same thing.
Yes.
Yeah, we're having some connection error.
I mean, what I
And
mean
you are back now. There was some internet connection problem, I believe.
is that getting, I mean, stuck or something?
Yeah,
You're good
it's
now.
getting better. Maybe one thing you could do, maybe just turn off your video. Sometimes the video can cause some bandwidth.
Uh,
And see if that improves.
Hello?
Yes, Anta,
Yeah,
I can hear you.
Yeah, I'm sorry, maybe
Ayanta.
there's, can you hear me, Dr. Maru?
Yeah, I'm here, and then suddenly, it is just going on. But now I can hear you.
All right. Okay, let me explain it again. Maybe, the connection problem or something.
Sure, if you don't mind.
So what we have done here, hello.
Yes, Anta. It's going back and forth. It's difficult to
and
tell.
you can like turn off your video, okay? It
Turn
will
off your video.
So
Abdullah, I have a question if you're available to answer.
okay. Is tell me the
Because I
question.
think Ayanta is having connection issues. Well, I have a question related to Dr. Roots about, so is each sample within the time series labeled, or is it just the whole time series given
So
a
it's like
certain label?
yeah. Thank you for your answer. Actually, for each sample, so it's like a individual time series. For example, like my bearing A, it has a time series 1, So it will cover, then while I start a machine, so then it capture like a whole vibration signals for a certain time for bearing B, and then I will start the machine and it can capture the the certain time to capture the
Yeah.
vibration signal. So they are individual, they are not
Yeah.
all together.
So yeah, I get that they're individual, but how are you labeling them like a fault or not a
So
fault?
so it's like predetermined. So in the like a machinery fault. So, for example, while we use like a good bearing or baseline bearing, so we capture the signal. So then we label it as a like a baseline and good bearing. And then while we set like a
Okay.
different types of fault environment, and then while we start the machine and then we capture the data, and then we label it like a faulty. But we label the different types of fault classes. So the what type of like a faults coming from based on like a faulty bearing.
So
For example, if the
yeah,
bearing is
so that makes sense. So if you have a faulty, so in the machine you put in a faulty bearing and then you run it and capture that signal,
right,
and
right,
and you run that multiple times with multiple different sensors to collect that data,
right, right,
and
right.
then that's your baseline for a faulty bearing, and then that's the same. Then you'll run a normal bearing and capture that vibrational signal there as well, right?
Right, 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 right. And then we classify those signals in two different things, like all like one class by like the rest of class, so one versus all. So, for example, I can take my good bearing as a class like a 0, and the rest of the like other bearings, do they are mixture of different types of faults, then I can classify like a one class, and then we can train and test based on chunk of our data set in that like artificial neural network, and then we can test our accuracy, how the machine can exactly like detect or what is that like
Yeah.
fault class.
That part makes sense to me. What now? So you guys used multiple different sensors. What would be like the difference between like the vibrational signal and maybe some noise signal within the machine? Like I'm confused at what some of the sensors you guys were using.
So actually, in our case, actually, we are using currently we have used like two type of sensors. So one is vibration sensors and another is acoustic sensors. Okay, so
Okay.
what we did we captured the vibration signals from 6 different locations. So for example, in a shaft, so we have two bearings. So in each bearing house, we set like a three say like accelerometer data on those bearing house one, and then if it is a bearing house two, and then we set another three accelerometer sensors over there. In the meantime, we also used the microphones in different locations of that like nearby the machine, so we captured at a time vibration and acoustic signals at a time, and then we interpolated those vibration acoustic signals in the same data range, so that the vibration signals has a different frequency than the acoustic signals, but we make it in the interpolated in the same same data a structure, and then we combined all this like a vibration and acoustic signal together, and then we use those signals in the like artificial neural networks.
Okay. So are so you know so are you testing for faults at different points within the machine? Like so you said
Yes.
you have vibrational, so you have multiple gears, for example, and you're testing the vibrational. Do you put faulty gears in every single spot or just at one spot or another?
So so currently we're using only the bearing force data. So in a bearing force, so it is as a bearing house over there that holds the bearing. So in a single bearing house, so we used there are different channels over there, the holes over there. So for example, in a bearing house, there are like 6 or 7 holes, but we specify three specific holes, and we use the accelerometer like a 1, 2, and 3 places. We use that like accelerometer on the bearing house 1, and then another bearing house 2, exactly the same location, like the compared with like bearing 1, and then we use the accelerometer like 1, like a 4, 5, 6. So that is like a 1 to 6 is like all the vibration signals coming from like a 1 accelerometer to like a number 6 accelerometer. And similarly, same goes to like a microphones, but microphones are not like attached with that like the machinery. Actually, it attached that nearby the machinery, so it captures that like a sound while we run the machine.
Okay. Interesting. Thank you.
Yeah, thank you.
So, Bapi, just one.
Does anyone else have any
sorry.
other questions?
Yeah, Abdullah, one question actually.
Go ahead, Dr. Murphy.
So whenever
Yes,
you,
that's right.
oh, okay, Ayant is also here. So whoever answers. So whenever you did the classification, did you do it for individual bearing, or you take all the bearings into account and perform that classification?
So, for example, while we use like in like a good bearing, for example, in a shaft, so there are like two supporting shaft, and then two supporting shaft, there are two bearing. So then I run that like whole experiment using the like a good bearings, and then I convert it into like a class 1 that is baseline bearing. And then second time what I did, I
No, I'm actually
mixture.
asking Abdullah about the algorithm side. So let's say whenever you implemented some, let's say, SVM or ANN, whatever be the technique, did you apply for each bearing, or you accounted all the bearings and then perform
So
the?
we applied
Let
like
me
a whole toolkit.
let me ask.
We,
I mean, can I answer the question?
Yeah, Anta, if you can go ahead.
Yes, yes, Dr. Marov, for your specific question, answer is yes. So answer is yes means that we use specific bearing, not all bearings together.
So that's actually because the way you set things up, then it just needs to be applied for each bearing, right?
Yes.
And then you get the classification error, and I believe at the end you sum all of them or you average them, something to get that over.
Yes, Dr. Maruf. For a certain bearing has a certain scope of use. So for this analysis, we use for the demonstration purpose. We just use for one bearing. So there's no such a cross-validated thing in there. So for the demonstration purpose, we just run this classification, and we tested only 20% of. We train 80% and just test on the other rest of the 20%.
How would you know a machine is needing maintenance if you're testing all the bearings? Is there like a pipeline, or are you just averaging accuracy, or are you just doing maintenance on each fault that breaks?
Yes, that's a quite good question. So initially we start from one bearing. So one bearing means that we just tested on how the folds are there. I mean, how the folds are. Means this is such a classification, which means that it is categorized under fold diagnosis. This is not just a prognosis. So we have these identified folds or identified certain states. After we have these certain states, we can alarm this system that so most of the parts are somewhere in fold state or defective state or normal state. Did you get my point? So if it is, most of the time, when we collect the data from a new, from this certain bearing, if it is, if it is collected under operating condition, but if it is falls under normal state, we don't need that attention to motivate this predictive maintenance. Otherwise, if it is falls under failure state or defective state, one can alarm to do this predictive maintenance.
Okay.
Does that answer your question?
I think that makes sense. Dr. Murphy, do you have any other questions?
No, I think that's all. Just wanted to say, well, you guys did a great job, and
Thank you,
it's
Dr.
actually not very easy, of course, to to work with some of those data sets, and actually I mean, it requires seems to be some pretty good pre-processing. Like if you are just maybe having the data set and you are manually labeling them, I mean, of course, depending on the size of your data set, it may take some time and some domain knowledge, and specifically the threshold, like when, at what point, of course, you can visually examine that, but at what point it gets failed, we can see that. But at point when it turns from healthy state or normal situation to, let's say, somewhat, what is the next level? Maybe like maybe it is started to get deteriorated. To find out that level, or like it is getting, the condition. Let's say if you classify into 3 stages. So one stage, they are good. Okay. Then another stage maybe a stage when things have started to make some changes, but you don't see at that point by just examining just the pattern. And of course, there's another stage when we can see that it just started to jump off or jump down or jump up, depending on your setup. Then at that point, we can see, okay, well, now things have been changing. So that is easy to detect, but there's always some internal change that before we get to that point, it is difficult to keep track. So it seems like there's some pre-processing that you need to do, and there's some domain knowledge, and there, and that can perform different from one bearing to another bearing. So it's probably not be the same threshold that you can use for all of them.
Yes, that's correct.
Okay, good job. Overall, good job.
Ayanta,
Yes.
I have one question. Like, I see you have used ANN.
Mm-hmm.
So then you have extracted the high level features manually?
Yes.
Okay.
It is actually handcrafted features, as I mentioned, because the time-dependent data is being transformed to FFT, or frequency domain. After that frequency domain, we grab certain features. I mean, we calculated the mid-level frequencies and high-level frequencies for calculating the power for this spectral density. So we use that information. This is definitely categorized under handcrafted features, as we did some analysis, and we end up with somewhere a feature called a spectral density. There are so many features, as you mentioned. We can use CNN or any other type of algorithm, so then the features are going to be different. So the automatic extraction maybe can maybe the automatic extraction also can be done. So if you go with the CNN type of algorithm.
So thank you very much.
You're welcome.
Well, I think that's all the questions. So thank you, Abdul and Ayanta, for presenting. And this, for anyone that wants access to this video, it'll be saved and put on YouTube.
Thank you very much, Christian.
Thank you, Christian.
Thank you.
So
Thank you.